Hello everyone. In this section, we're going to talk about transaction processing. So, what are transactions? In database systems, transactions means like user programs. The user can write a program that either read or write data, items to the database system, from or to the database system. So, transactions are basically not only queries as we discussed before. The user also can update the data, can write the data, or and can do a mix of all of them together. And the transaction is just one program from the user perspective that needs to run against the database. These transactions, we might have multiple users using the database, or even if we have one user, you might have multiple transactions running at the same time. So one way to run transactions that come at the same time is to have a queue and run them one by one. But this will not lead to a good performance in the database system. So this is why database systems researchers in the past few decades, they came up with techniques to achieve concurrency among different transactions that run against the database system. So the idea here is that the users will submit transactions, and then the DBMS will try to interleave the actions. Actions means here, they mean here read or write of data. So interleave the actions of multiple transactions, but such that each transaction leave the database in a consistent state. So if we take a look here, this is the database before the transaction starts. The database before the transaction start is in a consistent state. What we mean by consistent state here is that all the integrity constraints of the database are satisfied. Everything is fine. The rule here is that once a transaction started till the transaction ends, it also leaves the database in a consistent state. In between, the database can be temporarily in an inconsistent state, which is fine, as long as we start in a consistent state and leave the database system in a consistent state. So to achieve all these kind of requirements of a transaction and concurrency, do concurrency control in database system, there are four main principles of transactions. So the first principle is called atomicity, consistency, isolation, and durability. And we call these the ACID properties of transactions. It's ACID because it's an acronym for atomicity, consistency, isolation, and durability. And now we're going to see what each one of them means. So atomicity. Atomicity means that every transaction, which is again a program, a database program that has reads and writes, a set of reads and write operations on data in the database, needs to be atomic, which means that all the actions in the transaction needs to run in their entirety, all of them, or none of them run at all. So from a user perspective, the user has either will receive a message whether the whole transaction ran with all the actions in it, reads and writes, or another message would be like none of them has actually run. So this is why we call it atomic. The transaction, all the actions is an atomic unit. Consistency. Consistency means that there is no violation of integrity constraints whatsoever. So there are so many constraints that the database designer can define on the database. So, and consistency in that sense means that the transaction which executes has to, as we mentioned already, has to leave the database in a consistent state. So integrity constraints can mean so many things in database system, which are like the sanity of the data, the correctness of primary and foreign key, and referential integrity. There are so many integrity constraints in database systems. And as we're going to see later in the course, there are also consistency in terms of if we have data redundancy or data replication, how can we achieve consistency of the replicas of the data? That will also be included here when we talk about consistency, but we'll talk about that later. So in other words, you can think of it, if you're talking about programming, transactions need to be like a correct program. Like it's not exactly a program that you write in Java, but it's from a database perspective, it's a program, and this program needs to be correct and bug-free, for example. That's what we mean it doesn't violate integrity constraints. So integrity constraints, when they're violated, these are bugs for database systems. So we need to avoid these. Then we have isolation. So isolation means that each transaction needs to run as if there's no other transaction running in the database system, even though there might actually be other transactions running concurrently. But this concept will ensure that each of these transactions know nothing about the other transactions that are running concurrently, and when they start and until they finish, they're totally isolated. So this means we cannot reveal the results of other transactions to another transaction before the transaction is committed. The last concept of the asset properties is durability. And durability means that whenever you have a transaction and the database system says to the user that the transaction committed, this is kind of a contract between the database system and the user. And this contract must be honored. In other words, that when the database system says that all the updates in the transactions are committed, it has to be up to that word, even with the existence of system failures. If the computer fails, if there is any crash, or whatever kind of failure that happened, if the database system said we committed the updates, so that means the user will have to have committed updates. So these updates are persistent in the database. And in response to given all these kind of asset properties we talked about, the database system has some techniques and algorithms to ensure these properties of transaction processing and concurrency control in the database engine. So what are the examples of transactions again? So we've talked about transactions, but what are these? So we said transactions are a set of reads and writes into the database. Example is T1 or transaction 1. So transaction 1, what it does basically is that we have two accounts. This is the first account A, and we have account B. All what it does, think of this as a bank account, like bank account A and a bank account B. This transaction has a begin and an end. So the transaction begin, and the first operation is to read the value of A, and then update the value of A by adding 100. These are $100 to account A. And then read the value of B and updating the value of B by subtracting $100. So in other words, this transaction, if you think of it from a banking perspective, it transfers $100 from B to A. $100. That's basically what it does. Another example of a transaction is transaction T2. And in T2, you also read the value of A and update it, and read the value of B and update it. But also, if you think from a banking perspective, it adds interest to each of these accounts. So it has a begin and an end. So it should have an end here. And it adds the interest to the account A. That's how it adds it. So it updates it as like this 0.6%. And it does the same to account B. It adds an interest. So it also updates both of them. So this is an example of two transactions. And these two transactions can come and run concurrently against the database system. And we are going to be seeing how we can run them concurrently and what kind of issues can arise if we interleave the actions of these transactions. So if we interleave them like this, so from the DBMS, if they both come at the same time, you can read A and write A, this is the adding the $100. And then next, transaction T2, you also update A. And then you go back to transaction T1. So as you can see, from a database perspective, if you run them concurrently, you can interleave the actions of T1 and T2. This is the time interval. So as you go, the database system, which operation it runs first. So you go from left to right. So you can interleave the transactions. What is the right order of these actions? What is the right order we can interleave, and what can be correct and what can cause an issue to the application and to the database? We're going to see that in the next class. Thank you.